Okay, thank you everyone for joining us today, the delegates and everybody who is watching online. I'm Bruce Miller, VP of Product Marketing for Xirrus, and this is our second wireless field day. We're a pleasure to be here, and we are actually going to go through a round two, what we actually covered the first time around when we got into some of our architecture and what we do under the hood. We polled some of the delegates here and got a lot of questions about how we handle interference, how we handle all these radios working within the array, how we scale that architecture. So that's going to be what we're going to be talking about here today primarily, is looking under the hood and going into another round on that. We have a full suite of products. We'll give you a couple sampling of some of those things, but we're going to focus on the architecture of the product. So we'll get into the antenna design specifically. I'm joined here today with Dirk Gates, who's the CEO, founder of Xirrus, and the executive chairman today. Avi Hartenstein, who's our director of RF engineering, he's going to get into the antenna design, and then we'll follow that up at the end of the session with some examples of real-world performance testing and real-world customer examples that we've had. So at that, I'm going to give it over to Dirk to take us from here.
Thank you, Bruce. And I will echo Bruce's sentiments. Welcome to everyone online, and good to see everyone here again. We're excited to be back. And as requested, last time I was here, I've dragged my director of RF engineering out of his cave and forced him to put on pants and come up here.
Thank you on both accounts.
And you're welcome to address you guys today. So I think his section will be very interesting. I'm going to go through some overview of the company just to make sure we're all caught up of what we do. But first, it is Throwback Thursday. So in honor of Throwback Thursday, I did my best to sort of find a picture of me 20 years ago. So can everyone remember where they were 20 years ago? Some of you guys look like you were in elementary school.
Yes.
So do we remember the state of wireless LANs 20 years ago? 20 years ago, it was mostly 900 megahertz. What was going on in the ISM band in those days were cordless phones. And at Xircom, we had just introduced 20 years ago, this is 1994 is when we're shipping, it was introduced in 93. It was 5 years pre-standard. We had just introduced what is probably you can recall as the world's first wireless LAN access point as we know it today. If you go back 20 years, the traditional thing was to pull an ISA-based wireless LAN card and an Ethernet card, put them in a PC with some bridging software, and that was an access point. We were the first to integrate it, and so I'll pass this around. And we also introduced the world's first wireless LAN PC card. So this is a 2.4 gigahertz frequency hopping 1 megabit per second card. This is 1994. So if you guys ever wonder where that frequency hopping PHY came from in the standard, how many people have been through the standard and looked? That was us. That was the Xircom team of the day. Back in 93 timeframe when we were designing this, couldn't get the direct sequence circuitry to fit in a PC card. So we actually ended up doing a frequency hopper. This has got a little NEC embedded x86 microcontroller that does all the hopping algorithm. I'll pass these around, but that's what we were up to 20 years ago. The other thing that I have is, if you want to look, for those who are really geeky, see, we're keeping up with the actual, this is the innards of the access point. And I'll pass this around. What's really fun is to look at the date codes on the chips and the date code on the PCB. If you actually get at the right angle underneath the Xircom logo, 37th week of 93 is when the PCB was fabricated. So I'll pass that around for folks to play with as well. So that is the world's first wireless LAN PC card, 20 years ago, shipped 20 years ago this month, and probably the first of what we think of today as an access point. So other piece of trivia, the industrial designer that designed that housing for me, same person still working for me, designed the array housing. So
right, was it 1 meg or was it less than 1 meg at that stage?
This is 1 megabit per second frequency hop.
Out of the art.
Yeah, and the access point's actually kind of interesting. If you go back, you got to remember where things were 20 years ago. I think if you had a cell phone, it was a brick. Cordless phones were what was the norm. in the ISM band. In fact, what's interesting, if I pull out, I actually found this in the attic. It was shrink wrapped. I popped the shrink wrap last night to pull that access point out. But the couple of interesting things to note, we were using the term cordless, drawing the analogy to cordless phones 20 years ago. The other thing that's interesting is this was an access point for Ethernet. There's also one for token ring. You guys remember back before Ethernet 1? You had to do Ethernet and token. Anybody remember ArcNet?
Fiber channel over token ring.
Not 20 years ago.
Take that from him, we could get it working.
You know, this has got all the manuals and the CDs. If you could find a version of Microsoft, let's see, it's pre-Windows, I mean, it's probably Windows 95. Windows 95 would probably run that. So early days, fun stuff. Going back 20 years ago. So that's getting totally geeky, but as you can see, I've personally and a lot of the team at Xirrus has been around this for a long time. We've come a long way. 1,000-fold increase in speed in 20 years. That's pretty cool.
What was one of these running when you were selling it back then?
That had to be, it was under $1,000, but it probably was.
I think the press release said $999.
It was $1,000. So that would be in today's dollars, $3,000. I mean, it'd be expensive in today's dollars. Yeah, it was pricey. So.
It looks like a George design. Yes, I got one.
Yeah.
Funny thing is, Blake's still designing networks with your product.
Still use those things. So yeah, 1,000-fold increase in speed. If only the automotive industry could keep up with that. Actually, it'd be rather dangerous. Okay, so that was fun, totally geeky. Let me do a quick overview about Xirrus so we all get level set again for the guys, new guys in the room, and for the folks out online. You know, when we look at wireless, we see 4 key challenges that wireless vendors in the industry today have to solve. First is how do we create a scalable network, because the number of devices that are coming onto the network is just exploding, and it's going to continue to be that case. I think last time I was here, I may have been carrying 3 wireless devices, but now, even though they're not Wi-Fi, throw in my Pebble watch, throw in my Fitbit, throw in my Jambox, I'm probably a walking around, traveling with 6 wireless devices when I go set up in a hotel room. So scalability is going to become important. And then performance, especially for business-oriented Wi-Fi. You want to make sure your apps, your mission-critical business apps are running well, and try to prioritize those over the other things going on in your network. And also, just the rapid pace of change. 11AC is a testament to this. You've got to figure out, how do I keep up with the pace of change? How do I design a network and a solution to allow it to change as standards evolve quickly? And then the last piece is wireless LANs have just become increasingly complex. And so the question is, how do I tame the complexity? How do I make that simpler to use? And so at a real high level, with the Xirrus solution, we handle scalability by having the widest product line in the industry, from 2 radio devices all the way up to 16 radio devices. So depending on your application and your needs in a particular location, you can dial up or down the capacity and the performance of your network. In terms of performance and making sure that your business mission critical applications are running, we have embedded in each one of our products deep packet inspection, full application control, layers, all 7 layers right at the edge. So you can protect your network and prioritize those applications as the traffic is coming in and out of your network. So this has been a huge game changer for us. I think it'll become the norm for the industry to be able to manage those applications, throttle them, identify them, block them if necessary, right at the edge. In terms of managing the change in the industry, we've got a product line that is future-proofed. We've done for Wi-Fi what the chassis-based switch did for Ethernet. Give you the ability to swap out line cards and upgrade your systems as technology changes. So at the high end of our product line, we have modular devices that have individual radios that can be upgraded and swapped in the future. And then lastly, how do you make it easy? And so we, as probably is becoming the norm in the industry, we're allowing you to manage your network with multiple solutions. Probably the easiest and the simplest is a cloud-based solution that can automatically activate your devices, get them licensed, download a profile, and all through the cloud, which makes it very simple to do. And in fact, I'm not going to spend a lot of time today on our management or cloud solution, trying to leave as much time as possible to talk about RF. So we might have to come back a third time and talk about the cloud. But I would like to give you a quick peek at what that cloud piece looks like. And what's the, what do I do here?
Command tab.
Command tab, so.
When did the cloud product come out? Because I think last time you were here, that was not on the topic of conversation.
Right, so the cloud, this cloud was launched
October.
October.
But we had a cloud solution starting in January of last year.
Right, so we had a sort of a more enterprise-focused cloud solution. This one's actually a cloud solution that's been designed for in the 1 to 10 to 100 arrays to make it very simple to deploy and quickly deploy a network. And what we're looking at here is this is the dashboard of my wireless LAN at home. And so some of the things you get to see is who's the top user, how much data throughput, how many stations online. You can see I peak up to 20 stations. My biggest problem, this is my 13-year-old son. That's his iPhone.
I think
Why
that was pretty obvious when you saw that. I'm like, that's a kid.
Sorry, that's a kid.
I was going to say your bigger problem is going to be you've got 10 arrays at home. Like I'm good with 5, 7 APs. but
Large
good
house.
Lord.
Yep.
I bet you can beat that.
I've been known to.
So yes, I do have 10 arrays at home, and probably collective over the 10, probably 40 plus radios in the air. It is a large home, but it is well overbuilt because I also use it as a sort of a test lab. My family are guinea pigs for the company. So this is one view, and if you take a look at, this one's interesting as well, if you look at the applications, my family and my kids are watching too much streaming media. Half the traffic in the house is streaming media, and then goes on down from there. What's also interesting is when the two older boys come home from school, they're too smart. They're both gone to engineering school, and they find ways to hide what they're doing at home. So the unidentified HTTP traffic, those are my older boys hiding behind whatever tools they have so that I don't know what they're doing. Always wonderful. So, and then the other thing that's interesting in the house is we're a very tablet-centric family. The majority of the traffic is on tablets, followed by notebooks and phones, pretty close. And so the kids have given up their gaming consoles for their phones and tablets. Nothing interesting. And then, yes, I do have 10 arrays. Far too much traffic in the bedrooms. Got to pull the PCs and the tablets out of the bedrooms, in the kitchen, the family room, and it goes on down from there. So, but it's a very easy to use interface. The depth and richness of the configuration side is great, but again, in the interest of time, we'll do that next time we're up here. But it's just a wealth of fun information. So back to the presentation. So that, at a high level, are sort of the 4 things we focus on. As a refresher from the last time we were up here, the array architecture. If I pop the lid off of this again. There we go. So here's the array. You'll see that central to this is the controller, what you would think of as a wireless LAN controller with multiple gig uplinks. And then there are individual, think of them as line cards or radios that can snap in and out in various slots. And these are replaceable. They are user replaceable. More often than not, it's one of our VARs or channel partners that would be doing the upgrades. These happen to be 2x2 11N radios. They can be popped out, replaced by 3x3 11AC radios. And in fact, I'm trying to remember the exact number, our largest, so if you think about our business, about 1/3 of the radios that we ship go out 2 at a time in a device. And about another 1/3 of the radios we ship go out 4 at a time in a device. A mixture of 4 radio devices plus 8 radio devices with 4 slots empty. And that's about a 50-50 mix. So you're going to think about 15-20% of the products are going out with empty slots. And then about 1/3 of the radios ship 8 or 16 at a time. But there's a lot of empty slots that are being purchased with the thinking that they'll come back and populate those with AC radios when they're available. So I think this went around last time. I'll go ahead and start it if you'd like to see it again. In fact, we've been selling AC radio upgrade kits now for...
Since October of 2011.
Yeah, since October of 2011. We'll start actually shipping those. We've been selling them, pre-selling them. We'll start shipping those end of this quarter, beginning of next quarter. So those folks will actually get their upgrade radios. So the array concept here again gives you the modularity for upgradability. Each of these has a directional antenna. Avi's going to go into detail on the antenna design and how that works. In addition, each one of these array devices has an integrated controller. Even our 2 radio device, all the way up to our 16 radio device, have multi-core processors, 64-bit Cavium network processors, going from 2 cores to 6 cores. So a lot of horsepower. In fact, when you get to the 16 radio chassis, you've got 4 gig uplinks plus a 10 gig uplink option. So lots of uplink. So the newest product in the family, and I think we've got one sitting here, is our 11AC AP. This will be shipping by the end of the quarter. It's in beta right now. But is essentially what's unique there, again, is it has dual AC radios. Both radios are dual band, can be 2.4 or 5, 11N or AC, software programmable. So I think what you'll see today is a lot of these things will go out. I mean, the stock configuration is 2.4 and 5, but over time, you can start turning on more 5 gig radios in your environment. So also, this device supports the application control, deep packet inspection at the edge, has dual gigabit uplinks as well to be able to handle the backhaul, and has the cloud or on-premise management. Cloud management is great, comes out of the box, phone's home, gets activated, license gets pushed down, and if you've configured a profile for your network, it's automatically pushed down. So all of that happens automatically.
PoE requirements for that?
PoE is just T, just regular T. So and on the PoE, as you go up in size, we have all of the arrays are PoE, but I believe at the 4 radio point, it's a proprietary PoE. We have our own injectors. As well as we have 48 port gig switches with injectors built in that'll support the higher power array. So not that we really want to sell switches, we just think of selling a PoE solution and the switch comes along for free.
Is it acting more as a mid-span then, or is it actually just acting as a layer 2 switch?
It's a layer 2 switch with the PoE built in.
Right.
So you need to power them anyway. So we talked about the breadth of the product line. There are 2 devices down here, 11N, 11AC, 2 radio devices with fixed radios. The rest of the line are modular chassis based with replaceable radios, either 11N or AC, and they're upgradable. You can swap the radios in and out. In all cases, you get a multi-core controller built in. You get the DPI, the application control built in, zero-touch provisioning, and you get the, increasingly we're seeing our customers choose the cloud management. And in the cloud side, for us, cloud actually has multiple elements. One piece of it is we have cloud-based design tools that are available. Anyone go up to the website. You can upload a floor plan. It'll help you see what your design looks like with different types of arrays. And from there, when you buy your product, we have a capability we call Mobilize, which is our activation and license management software. So your arrays are automatically licensed and activated. And then you can feed your design into the actual cloud management solution, and it will then provision your arrays, push down profiles, push down all the configuration information. So sort of 3 pieces to our cloud solution. And like I said, we could spend an entire hour or 2 going into a deep dive in all of that software. So what does that mean when it comes time to deploy a wireless LAN? So this happens to be a floor plan of a convention center area, and this would be one way to do this. You just blanket the thing with 2 radio APs everywhere. Or, in this particular case, 114, or what the Xirrus solution allows you to do is pick and choose the number of radios per device. And in those areas where you've got large ballrooms and large amounts of users, you can use the 8 and 16 radio devices, get lots of capacity. In some of the meeting rooms, you drop down to the 4 8s. And in some of the offices and isolated spaces, just drop down to 2 radio devices. The net result is 29 devices versus 114. So you've got far less cabling, you've got far less PoE to deal with. Your total cost of ownership when it comes to the installation, cabling cost, product costs is about 20 to 30% less, and your time to deploy is significantly less. You can usually put a network like this, just looking at the ratio of devices, this will take a third the time or less to pop that network up. And so 11AC is sort of top of mind for everyone. And the marketing department, as usual, it's Throwback Thursday as well, decided to sort of borrow the AC/DC logo here and come up with our 11AC logo. So got any good metalheads out there that really into that, that's the logo. But what we're doing with 11AC that may be a little bit different than our folks, every radio is AC capable. It can be 11N, 11AC, 2.4 or 5 gig. It's software upgradable, software switchable, so you can program them on the fly. And in the arrays, you can actually pop out the modules, as I mentioned. And one of the other things that we'll talk about, I've got a slide coming up, is beyond band steering. If you have enough radios, you can start doing mode steering with something we call AC Express. Get AC clients together on radios and 11N clients together on radios. So we'll talk about that. So why is it important to have the programmable radios? Today, and sort of historically speaking, there have been probably more 2.4 gigahertz devices in the world than there were 5 gigahertz devices. But lately, as we've been seeing the data from trade shows and events that are being run on Xirrus equipment, we've actually seen that swing in favor of 5 gigahertz. So to the point where you now have 60% or more 5 gigahertz capable devices versus 2.4. And we believe 11AC will push that even further to 5 gigahertz. And given we have a lot more bandwidth up there, we want to use all of it as best we can. So being able to deploy your radios in a ratio that's appropriate for the client mix you have, and ultimately that is matched to the spectrum available. At some point, given there's 8 times as much spectrum at 5 gigahertz as there at 2.4, you would think your infrastructure should have 8 times as many radios at 5 gigahertz as 2.4. So the ability to go from this fixed paradigm that we've seen forever, where one radio is fixed at 2.4, one radio fixed at 5, being able to go to a paradigm where any radio can be in either band or either mode provides a lot of benefit, even with 2 radio devices, because you can still be looking at creating the right mix of radios in your infrastructure dependent on your client mix and dependent on the ultimately on the spectrum available. So what it means at the end of the day is you can push more traffic through your network.
So how would, I mean, if you've got a traditional AP with a 2.4 and a 5, the client connects to whichever the client wants to connect to if it's dual band capable.
Yep.
And with 2 5 gig radios, are they both, is it 180 degree in different directions? Is it 360?
In the arrays, Avi will talk at great length about how they're directional. And even in the 630, there's some directionality between the 2 radios.
Right.
So, and Avi's he breaks it down, shows you how the antennas are designed, go into that in gory detail, as requested last time. So, and we talked about band steering and mode steering. So think about, right now, if I'm connecting clients, you would hope that AC capable clients would choose 5 gigahertz over 2.4. I'm still amazed, I'm stunned at the number of devices that are dual band capable that still prefer 2.4. The first channel they look at is 1. They find a BSSID, they join it. And this is, we go back to the Throwback Thursday 20 years ago. Xircom was a client-oriented company, and we're guilty of helping draft a spec where decisions that should have been made in the infrastructure were made in the clients, because we were all thinking peer-to-peer mostly 20 years ago. So if there's something I regret in my past, is that we didn't get that right in the standard when we started. That's from an industry perspective, it's one of the things we have to do from a standards perspective, is move those decisions to the infrastructure. In the meantime, the best we can do is sort of help them figure out where to go. A lot of, I think almost all vendors have implemented some form of band steering. So if the device is probe requested on both bands, don't let them in at 2.4, wait for 5 gig.
It doesn't seem to be much push for that though, and there needs to be in the enterprise.
Yeah.
But it's because the SOHO market seems to dominate in sales, I guess.
Always has.
Yeah.
But what's interesting is someday we'll wake up and we'll realize that whereas the home consumer market led the industry, right now, pretty soon there are going to be more of these devices used on a daily basis in the enterprise than at home. And eventually we're going to wake up and figure out how to do that right. But meanwhile, we make do as best we can with the consumer-oriented protocols and solutions. What we do beyond band steering is, given that we have lots of radios in the environment and we can communicate between 2 radio devices and we can communicate between the radios within and between chassis, where possible, we start grouping 11 AC clients together on one radio and 11 N clients together on another, even in the 5 gig band. And it's just a simple extension of the band steering algorithm that says, if this radio already has an AC client on it, deny an 11N entry if there's an 11N radio that is suitable for it to get onto. And so basically it's not a black and white algorithm, but sort of a weighting algorithm that would gather AC clients together on one radio, 11N clients together on another radio. So that's something, again, you have to have enough 5 gig radios in your environment. Any given client hopefully can see more than one radio, 2 or 3 optimally, and then they can make that sort of steering decisions. So, go through this real quick. What's unique? This is the future-proofing, the building a chassis-based solution for the wireless LANs is unique to Xirrus. Deep packet inspection at the edge, every device is unique to Xirrus. True deep packet inspection, the same sort of engine that runs in the professional appliances, and a lower total cost of ownership when you take a look at cabling costs and equipment costs. Yes.
So I'm a big fan of modularity, right?
Yes.
Do you have a rough numbers about how many APs in total that you've ever sold have gone back and been retrofitted or upgraded or added? Are you talking about a small number of your APs? Are you talking like 80% of the APs ever sold have what percentage of people have taken advantage of the modularity?
Off the top of my head,
Yeah.
and I have to I'm going to say a third to a half.
A third to a half.
Yeah. Not everybody goes back through and updates that. So it's a great selling point.
Number.
People think about it, and a fair number of people take advantage of it. But there's also a fairly large number of people that it sounds good, but when it comes time for the next generation, they upgrade anyway.
Upgrade anyway. Okay.
Yeah, because the controller technology is moving as well. Not as fast as the radio technology, but it's moving.